Hi Year 12s. This is a video to explain how to sketch the exponential function. An exponential function is where we have any real number that is not equal to 1 to the power of a variable x. This can be represented as the function of a to the power of x. There are a number of rules that we can apply to any basic exponential functions. Number 1 is that any number to the power of -1 is equivalent to 1 over that number. Number 2 is that any number to the power of 0 equals 1. Therefore, the y-intercept is equal to 1. Number 3 is that any number to the power of 1 is equal to that number. Number 4 is that the x-axis is a horizontal asymptote. As our value of x becomes a greater negative value, then the function will become a smaller and smaller fraction, slowly approaching 0. Number 5 is that the domain includes all real numbers. Number 6 is that the range of the function is all positive real numbers. Number 7 is that it is only a one-to-one function, which means that every point on the x-axis corresponds to one, and only one, point on the y-axis. If we follow these rules, the basic function is not too hard at all to sketch. The main function we will concentrate on is Euler's number to the power of x, which is known as the exponential function. To graph this, we can just follow the same rules as the exponential functions that were just mentioned. If we represent the exponential function in the form of y equals a times e to the power of x minus h plus k, then we can see how the function shifts along the x and y axis. In this equation, h represents the shift along the x-axis, and k the shift along the y-axis, so our known coordinates will face a small shift. The graph can be reflected in the x-axis by placing a negative in front of the function to get f of x equals negative e to the x, and the graph can be reflected in the y-axis by placing a negative in front of the x in the function to get f of x equals e to the negative x. Here, we can see the black function is a reflection of the blue function in the x-axis, and the red function is a reflection of the blue function in the y-axis. It is also possible for a function to be reflected in both the x and y-axis. If there are translations applied to the function as well, you must first reflect the function before you translate them. If a function has a dilation factor in front of it, say k, then the image is multiplied by this factor. If the function has a dilation factor of x divided by k, then the image is dilated by a factor k from the y-axis. Let's now have a look at an example, such as the function f of x equals e to the 1 minus x plus 3. This we can rewrite quickly as f of x equals e to the negative x minus 1 plus 3. Straight away we can see that there is a reflection in the y-axis. No dilation, but there is a shift of the graph of 1 to the right and 3 up. Now we just need to apply this to our basic e function. Given the shift of 3 up, we know that there will be an asymptote at y equals 3, and that the function will always be greater than this. Since the function is reflected in the y-axis, we know that as the function approaches positive infinity, the graph will approach 3. To finish off, we just need to find the y-intercept by setting x to 0, as we know due to the shift on the y-axis of the asymptote that there can be no x-intercept. So, if f of 0 equals e to the 1 minus 0 plus 3, then our y-intercept equals e plus 3. Given there is no dilation, we can just draw the normal exponential function going through the y-intercept of e plus 3. There we have the graph. It's important to know these basic graphics of functions, as soon we'll be moving on to composite functions, which are combinations of different functions that we may need to graph. Till then though, happy studying!